Alright, if you've watched the previous couple of videos, you know that this is likely going to be a little bit longer of a problem, but we're going to hope that we can kind of smoothly move through it. We're going to jump right into our test, because by this point, you should know that if we have a matching pair, we would test whichever thing we don't have matching. So that's sine of big C. We're going to pair it up with little c times sine of big A all over little a. And what we're doing here is we're testing to see whether or not we actually have two triangles to work with, or at least whether we have the potential for that. Now I'm doing this quickly because I've chosen this problem to intentionally meet that condition. So we're seeing that this value is about 0.75, so we know that sine of C is between 0 and 1, so we have two possible triangles. Now we already knew this because that's what this video was titled, and that's what our page is titled. But it's important for us to see that. Now what I'm going to do is I'm going to take the inverse sine of our previous answer. And we're going to get that our C value, our measure of angle C, is approximately 49 degrees. In our last video, we saw we could come up with a C prime by subtracting that from 180. Now 180 minus 49, hopefully you know that that's 131. If not, just grab a calculator and test it out. What I do to check this value now is I take C prime and I add it to the angle that I was given in the start of the problem. I was given a 47-degree angle, and I'm seeing here, so this at a glance might look like this is going to be too much, but the 3 and the 4 give me 7. This is actually going to give me some interesting results. I'm getting 178 degrees. And a lot of people are going to go, oh, that's so close to 180. I mean, this must be too large, but what this tells me, I'll put a little scribble here. What this tells me is if I use C prime as a possible angle, B prime, our alternative B angle, would just have to be 2 degrees. There's enough room here for an angle. It's a tiny angle, but there's a little space left. I'll say since 178 is less than 180, we can use C prime. So we have two circumstances to work with now. I'm going to call this triangle 2, and I know that feels weird because it's on the left, but I like to think about my angle C as the first angle I came up with, so we'll call it triangle 1. And so now all I have to do is go, well look, in this triangle, let's go ahead and list out our known information between both of them. Both triangles said A was 47, C was 34, and A is 33. This is true for both triangles. But for this triangle, the measure of angle C is 49 degrees, and for this triangle, the measure of angle C prime is 131 degrees. Now we already laid out the groundwork on the left. We know that the measure of angle B prime is going to be 2 degrees, because that's how much we had left to get to 180 here. For this triangle, the measure of angle B will be 180 minus 49 minus the original 47 that we had. So if we just want to grab a calculator to save time, we're going to see that the measure of angle B is 84 degrees. Now, we have these two answers here for this triangle. We have these two for this triangle. We have 1, 2, 3, 4, 5 pieces of information for the left one, 1, 2, 3, 4, 5 pieces of information for the right one. Triangles have 6 pieces total. We're still missing the side length of B. But we know from previous statements that we can find that very simply by doing A sine of big B over sine of big A. Now on this side, we're going to call these B prime and A prime, and little b prime. And on this side, we'll just leave them as they are. And we're just going to go ahead and just run through the gauntlet of plugging in our values. So if you're comfortable at this point in the video, if you want to pause it, try it on your own real fast, skip to the end and see what those values end up being, that's perfectly fine. Now I wrote sine of a prime here, but to be fair, a was the thing that I was given originally. Over here, notice the only thing changing here is the measure of the angle we're working with. So here we go. On the left, we have 33 sine of 2 divided by sine of 47. And then on the right, we have 33 sine of 84 divided by the sine of 47. So I'm saying 1.57 on the left here, and I'm saying 44.87 on the right. And if you're worried about how different those values are, keep in mind how different the angles are. A 2-degree angle is tiny, so we should have a really small side length to go with it. And 84 degrees is much larger, so we should have a much larger side length to go with it. And there are our 6 values that we would have. We have one triangle solution set over here on the right, and one triangle solution set over here on the left.